Okay, this lesson we'll be doing Unit 2.1 of the IT Theory LB Grade 10. Okay, so Unit 2.1, they speak about data representation. So data representation refers to the form in which data is stored, processed and transmitted. Digital devices store data using binary number systems. Okay, so you can combine several of bits, which is zeros and ones, and if you combine 8 bits together, it is called a byte. So a byte can represent any number between 0 and 255. Here is just a bit of information which you need to know. Okay, so 8 bits is 1 byte, 1024 bytes is 1 kilobyte, 1024 kilobytes is 1 megabyte, 1024 megabytes is 1 gigabyte, and then 1024 gigabyte is 1 terabyte, and then 1024 terabytes equals 1 petabyte. Okay, so just know this information. Okay, so then Unit 2.2 is number systems. So this is basically the conversion of the number systems we did in class, like converting a decimal to a binary and a binary to hexadecimal and so forth. Okay, but let's start just from the top, a bit revision. Okay, so decimal number systems has the base of 10. So the numbering systems we use is called decimal system because of that prefix deci, that means 10. So just remember deci, 10 means base of 10. And obviously there are 10 numbers in the decimal system, which ranges from 0 all the way to 9. Okay, so it's not 1 to 10, it's 0 to 9. Okay, so the binary system has the base of 2, and the prefix bi is kind of where it has the meaning of 2, as in bicycle, biplane, bilingual, etc. And the two numbers here is 0 and 1. So not 1 and 2, but 0 and 1. Okay, so here's just how to count in binary. So converting from binary to decimal. Okay, so here's a few steps, but I'm just going to do this example to convert the binary 11000011. You can see it's the base of binary here at the bottom to decimal number. Okay, so first of all, we're going to start by writing out our binary number. Next, we're going to give this place values, so we're going to start from the right hand side and move to the left. Okay, but first we're going to start with 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, etc. till we get to the last column. Okay, then we can go and say, from the left side we can go and say, okay, so let's take 1 times 2 to the power of 7, which is actually 128. So 1 times 128 and then equals 128. Then we can add 1 times 64 is 64. Then we can add, okay, so 0 times 32 remains 0, so we don't have to do that one. 0 times 16 is 0, so we don't have to do that one. 0 times 8, we don't have to do that one. 0 times 4 is 0, we don't have to do that thing. Okay, then we get to 1 times 2 is 2, so we're going to add that to our answer, and then 1 times 1 is 1, so we're going to add that. Then altogether we have 128 plus 64 plus 2 plus 1, and that gives us a total of 195. So we know 11000011 in binary is 195 in decimal. Okay, then converting from the decimal to a binary, there's also a few steps. I'm going to do this example over here. Okay, so let's say we have the number 37 that we want to convert into binary. Okay, a very simple way is to firstly begin with your powers. Okay, so take your base. So we want to convert it to a binary. So begin with 2 to the power of 0. Okay, so then you're gonna go 2 to the power of 1, 2 to the power of 2, until your total, or 2 to the power of 2 equals 4, until that number is greater than the number you are converting. So if you go 2 to the power of 3 is 8. Is 8 bigger than 37? No, so then we carry on. 2 to the power of 4 equals 16. Is that greater than 37? No, it's not. So then we go 2 to the power of 5 equals 32. Is that bigger than 37? No, it's not. So we carry on. 2 to the power of 6 is 64. Is that greater than 37? Yes, it is. So then we can just basically stop there and delete that one. Okay, so then we're gonna start with the last one we got, 2 to the power of 5, which is 32. Okay, so what we want to do here is we want to see, okay, let's take 37 divided by 32. How many times does 32 go into 37? For simple sake, so it goes into 37 one times, and then we have a remainder of 5. Then we ask, okay, so our new number is 5. Can 16 go into 5? No, it can't, so we place a 0. How many times does 8 go into 5? It does not, so it's 0. How many times does 4 go into 5? So we've got 1 times. 4 can go into 5 1 times, and what is left over? So 5 minus 4 is 1, so 1 is left over. So then we go and say, how many times can 2 go into 1? It's 0. Then how many times can 1 go into 1? It can go into 1 times. So that will be our binary, 1 0 0 1 0 1. Okay, quite straightforward. Okay, then activity 2.2, we can just do 2.2.3 and 2.2.4 A to F. Okay, next up we've got the hexadecimal. Okay, so hexadecimal it has 16 numbers, so it has to the base of 16. It goes from 1 to 9, and when it gets to 10 it actually gets replaced by an A, and then 11 becomes B, 12 becomes C, 13 D, 14 E, and 15 F. Okay, quite easy. Okay, so here they explain again a few ways how you can convert. I'm gonna stick to this example. So to convert the hexadecimal number to BC, and we can see it's to the base of 16, to a decimal number. Okay, so first off, write what you have. So we've got 2, we've got B, we've got C. Okay, we need to convert that to a decimal. So converting to a decimal, I'm going to take my next step, which is my place value. So I'm going to start from the right hand side at 16 to the power of 0, 16 to the power of 1, 16 to the power of 2. Then I'm just going to simply go from my left hand side and say, okay, 2 times 16 to the power of 2, which is 256. That will equal to 512. So take that, and then you add B, which, if we remember from above, B is 11. So I'm going to take 11 times 16 to the power of 1 is 16. So that equates to 176. So I'm going to add that to my answer, and then lastly I'm going to take C, which is 12, and I'm going to multiply that by 16 times to the power of 0, which is 1. So 12 times 1 equals 12, So and then just add all of these totals together. 512 plus 176 plus 12, and that equates to 700. Thus 2BC equals to the decimal number 700. Okay. Now to convert from a decimal to a hexadecimal. Okay, so here's a few samples. Let me stick with this one. Okay, so I'm just gonna skip to the bottom and I'll explain in my own words. Okay, so here again, what we want to do is we want to take a decimal, convert it into a hexadecimal. Okay, so first off, we're gonna say 16 to the power of 0 is 1. Is 1 greater than 94? No, it's not. Okay, then we move on. 16 to the power of 1 equals 16. Is 16 greater than 94? No, it is not. Then we go to the next step. Okay, 16 to the power of 2 equals 256. Is that greater than 94? Yes, it is. So we're just gonna scratch this one out and we will be working with the last one. Okay, so that is 16 to the power of 1 equals 16. Okay, so this step, what we want to do is see how many times does 16 go into 94. Okay, so we can take 94 divide by 16 equals 5. Okay, so we're gonna write here 5. Okay, then we're gonna see, okay, but we now want to see the difference. So then we're gonna go 5 times 16 will be 80, and then 94 minus 80 should be 14. Okay, so that is our remainder. So now you just ask yourself, okay, how many times does 1 go into 14? And that is 14 times. If we can remember, if we replace 14 with the letter, we will get E. So our answer would be 94 decimal would be 5E in hexadecimal. And that is it for the conversions. Okay, activity 2.3, 2.3.5, A to D, 2.3.6, A to D, 2.3.7, A to D. And then we get to primitive data types. So you can read just this above. This is basically in practical all of our data types we do. So if we look at a boolean, it is for true or false. It can have a true, false, 1 or 0, yes or no. An integer is any positive or negative whole number. So that would be 1, 2, 5, 9, negative 20, etc. A float, or we call it a double, refers to any number with a decimal value. So 82.3, 0.9, negative 10.5, etc. Okay, next up we've got char. So a char is a data type that can store a single character. This includes letters, numbers and symbols. As you can see, A or 5 or exclamation mark or @ or small letter a, etc. And then the last one we have is a string. So a string refers to several characters, letters or numbers. They are surrounded by quotation marks to show where they begin and end, and it can basically contain all of the above. So for example, it can have a telephone number 0811111 whatever. It can contain hello world, it can contain a name, Maria Maseko, etc. Okay, and then just lastly, to activity 2.4, so 2.4.1 all the way to 2.4.5, it's just a multiple choice question basically, and then just 2.4.6 all of the questions, and 2.4.7 all of the questions. Okay.